Hi, Assalamualaikum warahmatullahi wabarakatuh. And very good morning, everyone. Alright, I'm sorry. I just woke up from my sleep, so. Okay, so yeah. Alright, so today we're going to continue our tutorial class with chapter 5.1. Alright. I was informed by Puan Ila that you guys have your lecture is until I think Dalton's law. So I will just like teach you until Dalton's law for this week, and next week we will go into the real guess versus ideal guess, and then we're going to 5.2. All right. Okay, so now we are going to, into this learning outcome, we are going to perform calculations involving gas laws and ideal gas equation, and define and perform calculation using Dalton's law. So that's what are we going to do in today's tutorial. So we are going to continue our tutorial questions on question number 5. Okay, so let's see question number 5. Okay, it states that a group of matriculation students carried out an experiment to determine the relative molecular mass of gas Z. The table shows the results obtained from the experiment conducted at 25 degrees Celsius. Okay, they got pressure at pressure in ATM unit, 0.25, 0.5, 0.751, and 1.25, and they got density in gram per liter, 0.6, 1.24, 1.78, 2.35, and 2.96. Okay, so now the question asks you, by plotting an appropriate graph, determine the relative molecular mass of gas Z. So they want you to find the relative molecular mass for gas Z. So now you got the temperature, you got the pressure, you got the density. Okay. So what graph are you going to plot? Graph of pressure against density. So you have to do the title, the axis title for x and y axis. So for the graph title, 1 mark. For the each of the axis, you got 1 mark. Okay, now you have to label. So this you use your graph paper lah. I recommend you use the graph paper. Okay. So since I don't have the graph paper, so I just like sketch this out lah. But you use it, but you draw this using the graph paper. Okay. So if you do the line punya graph, straight line, pressure against density, you will get this kind of graph. Okay. Where you will get this as your the gradient is your, what we call this, okay, sabar nanti kita terangkan. Okay, so this is your gradient lah, nanti you cari. Okay, now you look at, you need to derive this equation. So you know that PV is equals to nRT, and you know that PV also, if you look at N is equals to mass over molar mass, then you substitute that into this equation, you got PV is equals to mRT over molar mass. Okay, when you rearrange the equation to make this pressure as a y as a subject y, and the density as the x, you will get P is equals to RT over M times density, and we know that Y is equals to MX plus C. Am I right? So you will get like this actually. So P is, so you get P is equals to RT over M times density. So actually P is a Y is equals to MX plus C is equal to 0 lah. Because dia punya dia punya C intercept dia kosong kan? Kosong. Okay. So sekarang ni, we know that actually this P is under at y-axis, okay, and density is at x-axis. So that means the M is RT over M. So having said that, we will know that the gradient is equals to RT over M. This one. So the gradient M is actually equals to RT over M. So you need to find the molar mass, right? The M. So what we are going to do, we need to find what is the gradient. How to find the gradient? Okay, to find the gradient, M, as like macam fizik, y2 minus y1 over x2 minus x1. So y2 yang inilah kan, this is y2, this is y1, this is x2, this is x1. You kira, you will get around, I'm not sure, 0.4237, around like that. Okay. So you substitute the amount, this gradient is 0.4237, and then R is, since the unit pressure is atm, so you use the R 0.08206 liter atm per mole per Kelvin, and the temperature is 25 degrees Celsius plus 273, you got 298 Kelvin. So when you substitute everything, you will get M equals to, molar mass equals to 57.72 gram per mole, and the relative molecular mass is 57.72. Alright, so this is how you answer this question. Okay, please do this graph using your graph paper. Alright, okay. Next, we are going to answer the next question, question number 6. Okay, in this question, it says that at 20 degrees Celsius, 200 centimeter cube of hydrogen gas at a pressure of 100 kilopascal and 100 centimeter cube of helium at a pressure of 200 kilopascal are mixed in a 500 centimeter cube container. Calculate the partial pressure at 30 degrees Celsius for each gas in the container. Alright, so do you still remember the combined gas law equation where you combine the Boyle's law formula and the Charles law formula? So we get P1 V1 over T1 equals to P2 V2 over T2, this equation, right? Since we got T, we got V, and we got P. So this is all the combination of the Charles and Boyle's law. So, but we want to find the partial pressure. So means that we need to find the final pressure. So the P2. So when we rearrange the equation, we will get P2 is equals to P1 V1 T2 divided by V2 T1. So we know that for hydrogen gas, this is the T1, this is the V1. And this is the V2. And this is the T2. This is the P1 for the hydrogen gas. So I have state in this answer for hydrogen gas, P1 is equals to 100 kilopascal. When we convert it to ATM, it is 0.99 ATM. V1 is 200 centimeter cube. When we convert into liter or decimeter cube, we got 0.2. And the T1, 20 degrees Celsius, we got 293 Kelvin. Okay. For P2, we want to find the final pressure. So we don't know yet. So for the final volume V2, it is 500 centimeter cube. Okay, so we convert it into liter, 0.5 liter, and the final temperature is 30 degrees Celsius. So remember that the final volume, the final temperature is the same for both gas, hydrogen and helium. Okay, So we just want to find what is the partial pressure for each of them because it's different for because they got different final partial pressure. Okay, so when we use this equation, P2 is equals to P1 V1 T2 over V2 T1. We substitute all the information that we got into this equation. We got it like this. So P1 0.99 atm, V1 times 0.2 liter times T2 303 Kelvin over V2 0.5 liter times T1 293 Kelvin. So liter, Kelvin, Kelvin. So we will get, when we calculate, we will get the final pressure for hydrogen gas is, let me calculate. Okay, 0.99 times 0.2 times 303, 59.994. Okay, wait. 0.5 times 29, 146.5, 146.5, 146.5, 146.5. So we will get the answer 0.4 0.095 atm, 0.4095 atm. So this is what we got for the answer. Okay, next we want to find for the helium gas. So just the same, so we extract all the information from the question and list them down like this. So pressure for helium, P1 is equals to 200 kilopascal or 1.97 atm. V1 is equals to 150 centimeter cube or 0.15 liter. And the temperature is 20 degrees Celsius or equals to 293 Kelvin. And the V2 and the T2 is just the same as for the hydrogen gas. Okay. So just the same, we need to substitute all the information into the formula just now. So 1.97 atm times 0.15 liter times 303 Kelvin over 0.5 liter times 293 Kelvin. So we will get 0.6112 atm. So we got 0.6112 atm. So this is for helium gas. Okay, you may ask me, like, Miss, do we must use this equation? Can we use other equation? Yes, you may use other equation. For instance, you can use this equation. PV equals to nRT. We can find the partial pressure using this equation. How? Okay, just simple je. You can use P1 V1 equals to N1 R1 T1. P2 V2 equals to N2 R2 T2. Where you need to know, even at the different condition, N and R will be constant. So that means N1 equals to N2, R1 equals to R2. Okay, this equation also you can use lah. Alright, but it's just the same as this actually, because like if you cancel this out, you still get P1 V1 over T1 divided by P2 V2 over T2, just the same. But if you want to use this also, you can. You can see lah, maybe there's different in some of the answer, right? Okay. Now, we are going to look at question number 7. Okay. For question number 7, it says that a cylinder contains carbon dioxide gas at 6.5 atm. Alright. Enough carbon dioxide gas escaped from this cylinder into a 24.8 liter container to bring the pressure of this container to 1.05 atm at 21 degrees Celsius. So this is the pressure and the degree and the temperature at the container. Okay, if the volume of the container then change, what would the volume of gas be if its pressure goes to 1.28 atm at 30 degrees Celsius? So we use the same formula. Okay, since they have the volume, the temperature and the pressure, we use the combined gas law, which is P1 V1 over T1 equals to P2 V2 over T2. But now we want to find the final volume, right? The V2. So we just arrange the equation so that we can get V2 equals to P1 V1 T2 divided by P2 T1. So we list down all the information, we extract all the information from the question. We get P1 is equals to 1.05, V1 is 24.8 liter, T1 is equals to 294 Kelvin. P2 is the 1.28 atm, T2 is the 30 degrees Celsius, and the V2 is what we want to find, the final volume. So when we arrange the equation, we just substitute all the information that we obtained from the question into the formula. So what we can do is, so P1 is 1.05 atm times V1 24.8 liter times T2 303 Kelvin over P2 is 1.28 atm and T1 is 294 Kelvin. So when we calculate this, we will get the volume, the final volume is 20.97 liter. So this is the answer for question number 7. It's very simple. Okay. Now we are going to go into the new what we call it, not a unit, a new title, a new I don't know lah, a new what, but a new macam sub topic lah, a new sub topic. Okay, this is, so the subtopic is gas, but the sub topic is the partial pressure of gas and the Dalton's law. Okay, so first we need to know what is the partial pressure lah kan. So partial pressure of gas ni is the pressure exerted by a gas if it was alone in the container. The partial pressure ni partial pressure yang gas tu ada dalam container. Okay, and it can be expressed using the ideal gas equation like what we did just now. PA equals to NART over V, or we use the combined gas law, and we can use mole fraction. Okay, how we use mole fraction? So we know that this is actually mole fraction. Okay, mole fraction is equals to moles of A, contohnya, over total number of mole. So we know that number of mole, so we know that PV is equals to nRT. So N is equals to PV over RT. Okay, so we know that NA is equals to PAV over RT divided by total mole P total V over RT. So VRT is the same, right? So we just cancel. We got XA is equals to PA, pressure for A, over pressure total. So maksudnya the mole fraction of A is equals to partial pressure gas A over pressure total. So we get that the partial pressure for A is the mole fraction A times the partial pressure of the total gas. Okay, so note that XA, the mole fraction A plus mole fraction B plus mole fraction C and so on must be equals to 1. Okay, so it means that if there is a gas A, B and C inside the container, we need to find the so the total mole fraction of gas A and gas B and gas C must be equals to 1. Okay, so that is the calculation of partial pressure using the mole fraction. We will look into it after this. Okay, now we want to know what is the Dalton's law of partial pressure. So the definition for the Dalton's law states that the total pressure of a mixture of non-reacting gases is the sum of partial pressures exerted by each of the gas in the mixture at a constant volume and temperature. Okay, what does it mean by that? For example, in the container, when we have 1 mole of oxygen and 1 mole of neon gas, so this the total pressure exerted by oxygen and neon gas will be the total pressure. So that means the partial pressure of oxygen plus the partial pressure of neon gas will be the pressure total. Okay, so when we do the mathematical formula, we know that pressure total is equals to partial pressure oxygen plus partial pressure neon gas. So we know that it will be the number of mole of RT over V, the number of mole of oxygen RT over V plus number of mole of neon gas RT over V. You can pandai matematik kan, you can keluarkan this, you can get number of mole of oxygen plus number of mole of Ne times RT over V. So that means the P total, the pressure total is equals to N total, the total number of mole times RT over V. Okay, this is by the mathematical formula lah. You punya matematik lagi hebat daripada Miss kan. So you can derive this very efficiently lah. Okay, so this is the what we call it the mathematical formula for the partial pressure according to the Dalton's law. Okay, so now we want to answer a few questions. So let's look at question 8. So the question 8 asks you to state the Dalton's law of partial pressure. You can refer the notes in the lecture note or from the notes that I will be giving to you after this lecture note pun boleh juga. Okay, this tutorial note I mean. Okay. So now let's look at question B. It says that a gas mixture containing 2.45 gram of nitrogen gas and 3.10 gram of neon gas occupies a volume of 2.5 liter. Calculate the total pressure of the gas at 25 degrees Celsius. So they want you to find the P total. Okay, so for that you have to find the total number of mole, because if we use this equation, we can use P total equals to N total RT over V, right? So you need to find the total number of mole. So we know that we can find the total of mole by finding the number of mole of each gas first and then sum them up together. Okay, so let's find the number of mole for nitrogen first. So the mass it gives is 2.45 gram, and the molar mass for nitrogen gas is 28.02 gram per mole. So when you divide this 2.45 divided by 28.02, you will get 0.0874 mole. Okay, 0.874 mole. Okay, 0.0874 mole. Okay, now we want to find number of mole for neon. So mass of neon given is 3.10 gram. So the molar mass for neon is 20.18 gram per mole. So 3.1 divided by 20.18, we got 0.1536 mole. So when we combine the number, when we sum the number of mole of nitrogen with number of mole of neon, we will get the total number of mole is 0.0874 plus 0.1536. We will get 0.2410 mole. So this is the N total, the total number of mole. So from the derivation above, we know that the P total, the total pressure of the gas is equals to the total number of mole of the gas times RT over V. So we got the V here, we got the T here. And we know what, and we can use the R of 0.08206 atm. Okay. So here we know that the P total is equals to N total. N total here is 0.2410 mole. Okay, times dengan R. R we will use 0.08206 liter atm per mole per Kelvin times with T 25 degrees Celsius, so convert to Kelvin, 298 Kelvin, divide by the volume 2.5 liter. We will get 2.3579 atm. Okay, 2.3579 atm. Okay, the second question asks you to find the partial pressure in unit torr. So you need to convert this pressure into unit torr. So when we convert this into unit torr, please refer your lecture note for the conversion punya table. So you will get 1791.59 torr. So this is the pressure. Okay. Alright. Nice. Now, the second question asks you to find the partial pressure of each gas in unit torr. Dia nak partial pressure pula. Okay, how do you find the partial pressure then? Okay, we know that partial pressure of A is equals to mole fraction of A times total pressure. So, we can find the partial pressure nitrogen using the mole fraction of nitrogen gas times with total pressure. So, we know already the number of mole for nitrogen, the number of mole of neon, and the total number of mole. So, what we can do is, we can just substitute all the information that we already have. So, for instance, to find the mole fraction, it is the number of mole of nitrogen over the total number of mole. So the number of mole of nitrogen is 0.0874 mole over the total number of mole is 0.2410 mole. And the total pressure is times 1791.59. So we will get the answer equals to 649.88 torr. So this is the answer for the partial pressure for nitrogen gas. Okay, now we want to find the partial pressure for neon gas. But we know that according to Dalton's law, the total pressure is equals to the partial pressure gas A plus partial pressure of gas B plus partial pressure of gas C. So we can just subtract the total pressure with the partial pressure nitrogen gas to get the partial pressure of neon gas. So we know that the total pressure is 1791.59 and the partial pressure for nitrogen gas is 649.88. So that means we will get the partial pressure for neon is 1100 okay. What happened actually? It's okay lah. So 1142.11 torr. So this is what you will get. Okay? Alright. So remember that to find the mole fraction is the number of mole over total number of mole. Okay, so don't forget that. Boleh je if you want to find the partial pressure using the same formula as this. Sama je markah dia. Okay? Sama je markah dia. Alright. Okay. Now let's look at question C. Okay, question C. They ask you, a sample of ammonia gas NH3 is completely decomposed to nitrogen and hydrogen gases over heated iron wool. If the total pressure is 566 mmHg, calculate the partial pressure of nitrogen and hydrogen gas. Okay, so in this case, dia dah bagi you total pressure. So what you need to find is the number of mole and the total number of mole. So what we can do is, we can use the chemical equation since dia tak bagi kita the mass or whatever things to find the number of mole, right? So we can use the chemical equation, the balanced chemical equation. So we know that NH2 gas will be decomposed into nitrogen gas and hydrogen gas. So when we balance everything, we will get 2 NH3 decomposed into nitrogen plus 3 H2. So 2 mole, 2N, the coefficient 2 we will convert into mole. So 2 mole of NH3 will decompose into 1 mole of nitrogen gas plus 3 mole of hydrogen gas. Hence, the total number of mole is actually 4. 3 plus 1 because this one 3 plus 1 because we want to find the partial pressure for N2 dengan H2 kan. Okay, so we know that the total number of mole for the nitrogen and hydrogen is 4. Okay, so note that to find the mole fraction, we need to use the number of mole over number of mole total. So, to find the partial pressure A, we know that the mole fraction A times dengan P total will get the partial pressure A. So having said that, we can use that to find the partial pressure of nitrogen gas. We can find the mole fraction of nitrogen gas times the total pressure. We know already what is the total pressure. We just need to find the mole fraction. How? We use this lah. Okay, so the number of mole of nitrogen is 1. So 1, the total number of mole is 4. So 1 over 4 times the total pressure is 566 mmHg. So we will get the answer 141.50 mmHg. Okay, so to find the partial pressure of hydrogen, just minus total pressure minus partial pressure nitrogen. So 566 minus 141.50 mmHg, you will get 424.50 mmHg. So this is how you answer question 8C. Okay. Now, Boleh Alright, now we are going to answer the last question 9. Okay, yay. Dah habis dah. Okay. So now let's look at question 9. It says that at 128 ml of oxygen gas, a 138 ml of oxygen gas was collected from the decomposition of potassium chlorate at 24 degrees Celsius and at an atmospheric pressure of 762 mmHg. Calculate the mass of the oxygen gas obtained. The vapor pressure of water at 24 degrees Celsius was 24 mmHg. Okay, so the water and oxygen dalam decomposition ni. Okay, so we know that the total pressure is actually equals to partial pressure oxygen plus partial pressure water. So we want to find the partial pressure of oxygen first because we want to find the mass of oxygen using the PV equals to nRT thing, right? So we need to find the pressure first. So the P total here is 762 mmHg. And we know that the partial pressure of water is 24 mmHg. So when we subtract this, we will get 738 mmHg. And when we convert this into ATM using this conversion, 738 mmHg times, because 1 ATM is equal to 760 mmHg, we will get the pressure in ATM as 0.971 ATM. Okay? Alright, so now when after we know the partial pressure of oxygen, we can use to find the mass of oxygen. So we know that the PV is equals to nRT, and we know that N is equals to mass over molar mass. So we substitute it into this. So PV is equals to mass RT over molar mass. So since we need to find mass of oxygen, we will rearrange the formula to make the mass as the main subject. So mass is equals to PVM over RT. So we know that the P here is 0.971 ATM. V here is, look at the atas lah, 128 ml, but you need to convert it into liter. So 0.128 liter times dengan molar mass. Molar mass of oxygen is 32.0 gram per mole. Okay, so maksudnya 16 plus 16 dapat 32, okay. Divide with R we use 0.08206 liter ATM per mole per Kelvin, and the temperature is temperature in here is 24 degrees Celsius plus 273 Kelvin is 297 Kelvin. Okay, so now ATM cancel, liter cancel, per mole per cancel, Kelvin per Kelvin cancel. So we got gram. So how many gram we will get? Kalikan 0.971 times 0.128 times 32 gram. Divide by 0.08206 times 297 Kelvin. We will get the mass of oxygen 0.163 gram. Okay, so this is how you find the mass of oxygen. You need to find the partial pressure first because it gives you the total pressure and what we call this partial pressure of water. So that must mean something. So you need to find the partial pressure of oxygen. So dah dapat partial pressure of oxygen, then you can use the equation PV equals to nRT, and you can use the relationship with the mass and molar mass to make the equation to make the mass as the subject for the equation for the formula for you to get the mass of oxygen, for you to calculate the mass of oxygen using the partial pressure, the volume given, the molar mass, the R and the temperature given. Okay, so this is how you get the mass of oxygen for this question. Okay, So we actually have finished until question 9. Okay. So I believe that you can answer the objective question until question, I don't know, I think you can answer most of the objective question now, except for the ideal guess versus real guess. Okay, so for the ideal guess versus real guess, I will cover them next week. Okay, and we will also enter the new subtopic liquid. Okay, so I think that's all for today. I hope that you can understand on how to answer the question regarding this ideal gas equation, this Dalton's law, or the combined gas law, what is Charles' law, Boyle's law, and what you call it, Avogadro's law, and everything in this chapter. For now, okay, before we move into the real gas versus ideal gas thing. Okay, so that's all for today. Thank you for your cooperation. Alright, we will see you guys in the next video. Bye bye. Assalamualaikum.